Welcome, GeoTrig. This is 8-1, the Pythagorean Theorem and Converse. The essential question is, what is the Pythagorean Theorem? Let's begin. So the Pythagorean Theorem is this. You might have seen it in 8th grade, and you might have seen it a few times in Algebra 1 and Geo, but here it is, and you got to know it at this point. So if you have this only works for right triangles. A and B are the legs of the right triangle, and C is the hypotenuse. Then you can say a squared plus b squared equals c squared. A corollary to that is sometimes you say find the hypotenuse and you know the legs. So you can say c, the hypotenuse, equals the square root of the quantity a squared plus b squared. So just got to know that, just got to memorize it. Watch order of operations. Pythagorean triples. These are a special case when the non-zero whole numbers satisfy this equation a squared plus b squared plus c squared. So basically we have a right triangle here where the legs are and the hypotenuse are all whole numbers. So one example of that is 3, 4, 5. So the shortest leg is 3, the middle one's 4, and the hypotenuse will be 5. And that actually checks out, because if you plug that in, you get 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and that equals 5 squared. So these are some common examples. 3, 4, 5 will appear a lot, and versions of that like 6, 8, 10, just multiplying everything by 2, it still checks out. 5, 12, 15, 13 sometimes. 8, 15, 17 sometimes, and maybe this 7, 24, 25. These are just some examples, but you could see others later. Converse of Pythagorean theorem. So a converse of that says, hey, if we have three numbers that satisfy this equation, a squared plus b squared equals c squared, then the triangle that forms that is a right triangle. And that's what we're saying with those Pythagorean triples there. If you have 3, 4, and 5, you're going to have a right triangle there. Those are the lengths of the sides. Two others expanding on that converse that are kind of neat. If you have inequalities here, so c squared is greater than a squared plus b squared, this angle c right here and this line is going to be bigger, so this actually forms an obtuse triangle. That means one of these angles, this angle c, is greater than 90. So that's greater than 90. Now if c squared is less than a squared plus b squared, then you have an acute angle. That means all these angles are less than 90 degrees. All right. So a way to summarize this is right here. C squared is less than, it's acute. If it's equal, it's right. If it's greater than, it's obtuse. Let's do some examples. So pause the video. Okay, what is the length of hypotenuse of ABC? Do the sides of the lengths of ABC form a Pythagorean triple? Explain. So following this formula, I'm going to label this C. So it's going to be C equals the square root of a squared, 20 squared, plus 21 squared. This kind of stuff, I would kind of expect you to use a calculator. What does this come out to? 40 or 20 squared is 400. What's 21 squared? Well, you can do the math right here. I won't use a calculator. We can be strong. So that's 441. So 441. And that adds up to the square root of 841. Well, this is, you know what? Plug this into a calculator. If you plug that in, you're going to get 29. So C, that messed up on me, C equals 29. So there's your answer for C. So that's the length of the hypotenuse. Do the sides of the ABC form a Pythagorean triple? Yes, they do. Because when this is sides 29, a Pythagorean triple means they all have to be whole numbers, and they all have to satisfy that equation, a squared plus b squared equals c squared. So that's the answer. Yes. They're all integers, it's Pythagorean triple. So pause the video. Alright, so let's make another equation. Now, x is one of the legs. We can make a new equation. It's usually going to be x squared plus 8 squared equals 20 squared. You could write it like this and solve for x. So that's going to be x squared and plus 64 equals 400. I'm going to subtract 64 on both sides. What I get is x squared equals 336. And then so I want to square root both sides. Okay, and I want to answer this in simplest radical form. There's different ways that you guys reduce those. The way I do this, I do the step method. I don't care how you do it. So what number goes into that? Well, it's even, so 2. And then I'm going to factor 336 divided by 2 is going to be 168 divided by 2 again. So that comes out to 84 divided by 2 again. Comes out to 42. 2 again. Comes out to 2, 1. And that's 3 and 5 and 7. So 7's a prime, can't go farther. Got a pair of 2's and a pair of 2's. A lone 3, a lone 3. Pairs come to the outside, so the outside is 2 times 2. Inside is the square root of 3 times 7. So that reduces to 4 square root of 21. And that's your simplest radical form answer. Next one. Pause the video. Okay, so the triangle sides are these lengths up here. Is it a triangle or right triangle? Well, I'm going to sketch a picture of this. Now, the hypotenuse, the longest side, has to be the longest one of these lengths. So that's going to be 85. And the other two, it doesn't matter. One's 84 and one's 13. So I'm trying to see if this forms a right triangle. It's got to satisfy the equation c squared, so 85 squared equals 84 squared plus 13 squared. All right. And this, again, if you want to use a calculator, or you can, no, we're going to do the math ourselves, because I'm going to prove I can do this without even checking my work. You can correct me if I'm wrong. Okay, 40, so 42. That's 0, carry a 4. 4 times 8, 60, 68. It's going to be 6, 5, 2, 2, carry a 1. So that's going to be 7,225 equals 84 squared. So 84 times 84, 56 plus 69 is going to be, yeah, that's going to check out. So the answer is a right triangle? Yes, because the math checks out. You should probably use a calculator. Yeah. All right, next example. Triangle. Pause the video. Triangle has sides these lengths. Cubed, obtuse, or right. So we have this formula, c squared something, I don't know the sign, a squared plus b squared. So I have to figure out if it's bigger or less than that. So c has got to be the biggest one. This is c, and these can be a and b. It doesn't matter. So 14 squared, and you got a squared, 6 squared, plus 11 squared. Well, 6 squared is 36. I can do that in my head. And 121. I can do those in my head. 14 squared, 14 times 14. Let's see if I mess this up. Carry a 1. There's a 5, 4, 1, boom, 6, 9. That's 196. So 36 plus 121, 6 plus 1 is 7, and 3 plus 2 is 5, and then a 1. So we'll have 196. Well, that's bigger than 157. Since it's greater than, we're going to go with obtuse. And that's it. Done.